Dear students, welcome back. Let us begin the third part of the lesson in which you will learn about the Bonferroni procedure and its application. Bonferroni procedure is the simplest of all the multiple comparison tests. Each comparison is done by using an independent student t-test, but the corrected level of significance to which the p-value to be compared is to be changed to alpha by h, where h is the number of hypotheses to be tested. So, it is more conservative test because there is a chance that significant differences can turn out to be not significant because your alpha by h will be very small. So, which means it can contribute to be non-significant even the result is a significant result. The advantage of this method is that the number of comparisons, that is h, is equal to the number of comparison of interest in which the researcher is interested to compare. For example, if we have 3 groups to be compared, the all possible comparisons would be 1 versus 2, 2 versus 3 and 1 versus 3, but the researcher could restrict himself the comparison to only 1 versus 2 and 2 versus 3, and 1 versus 3 can be skipped if the researcher do not want to compare them. The smaller the value of h, the efficient the procedure is. So, let us apply the Bonferroni procedure for the same example. So, with the same research question we will start with. We are going to compare the first group and the second group in terms of mean against the alternative hypothesis mu1 not equal to mu2. For performing the Bonferroni test, we will perform an independent sample t-test using the test statistics which you are familiar with in the previous modules. So, the test statistic for independent sample t-test is given by t is equal to y1 bar minus y2 bar, because we are going to compare the group 1 and group 2 divided by the standard error of the difference, which follows a t distribution because we are going to get the table from the t table. Similarly, sp square is nothing but the pooled variance of these two groups, which has the formula n1 minus 1 into s1 square plus n2 minus 1 into s2 square divided by n1 plus n2 minus 2, where s1 square and s2 square are the sample variance of the first group and second group respectively. So, using this test statistic, you can compare the test statistic value with a tabulated value, and you can conclude based on the corrected level of significance alpha by 3. That is why I have made alpha as alpha by 3. Similarly, you can go ahead with the second research question comparing the first group with the third group. To compare this, we had the hypothesis, null hypothesis as mu1 is equal to mu3 against the alternative hypothesis as mu1 not equal to mu3. Again, for comparing these two hypotheses, we are going to perform an independent sample t-test. The t statistic is given by y1 bar minus y3 bar divided by standard error of the difference, that is the s pooled variance into 1 by n1 plus 1 by n3, and sp square stands for the pooled variance of first group and third group. Similarly, we will move to the research question of the third pair of comparison, that is second group and third group. The hypothesis will be h naught is mu2 is equal to mu3 and h1 is mu2 not equal to mu3. Again, we perform the same test with the given test statistics, and we will compare with the critical value of level of significance corrected at alpha by 3. So, after you perform all this thing, here I am skipping this because you have already done an independent sample t-test, so that no need to give all the details of the calculation. So, we will just take the conclusion whether to reject or accept. So, here from the table we can conclude that the comparison between storytelling and musical audio, the p-value is 0.019, which is less than 0.05. So, you are going to reject the null hypothesis that mu1 is equal to mu2. Similarly, for the second pair of comparison 1 versus 2, we are going to again reject. For third group also we are going to reject because the p-value is less than 0.05. So, from the above table, we can conclude the results of the Bonferroni multiple comparison test are performed for anxiety score among the 3 pain management technique are presented in table 5. It was found that there was a significant difference in the mean anxiety score between storytelling and musical audio and audiovisual, and storytelling and audiovisual. So, all mean anxiety scores are significantly different. This lesson introduced the multiple comparison test, which needs to be performed after the overall ANOVA is found to be statistically significant. For performing multiple comparisons, there are several methods. We have exclusively detailed only 3 procedures, namely Tukey's HST, Chef's method and Bonferroni procedure. We have also applied these methods to the case scenario and interpreted the results. I hope the concepts are clear to you. We have concluded and completed our lesson on post-hoc comparisons in one-way ANOVA. We will continue in the next lesson. Thank you.